For over 100 years, astronomers watched Barnard's star with growing curiosity. It moved faster across our sky than any other star. A quiet traveler, hinting that something unseen might be tugging at it. Could there be planets, hidden worlds caught in its gravitational grip? In the 1960s, one astronomer believed he had found them, only for his discovery to unravel. Decades of silence followed, but now, thanks to cutting-edge technology and relentless scientific pursuit, the truth has finally come to light. Not just one, but 4 rocky planets have been confirmed orbiting Barnard's star. One of them, a frozen super-Earth. The others, smaller than Earth, race in tight, scorching orbits around their ancient sun, a mystery that began in suspicion, endured skepticism, and ended in revelation, solved not by a single mind, but by generations of science. The year was 1916. Edward Emerson Barnard, a legendary American astronomer and pioneer of astrophotography, made a remarkable discovery. Through meticulous observation, he identified a faint red star speeding across the sky, faster than any other star known at the time. That star would later be named in his honor, Barnard's star. At just 6 light-years away, Barnard's star is the second closest stellar system to Earth, right after Alpha Centauri. But unlike its brighter neighbors, it's invisible to the naked eye. You won't find it sparkling in the night sky, not because it's far, but because it's small and dim. And yet it moves, over 10 arcseconds per year, the fastest proper motion of any star. Like a silent ghost slipping across the cosmos, it drifted through telescopic fields of view, hinting at something unusual. That incredible motion meant something important. It was close. And if it was close, could it have planets? Could it be home to hidden worlds that had escaped our view for generations? To understand the mystery, we must compare it to our own sun. Barnard's star is a red dwarf, specifically spectral type M4. That means it's only about 14% the mass of our sun, just 18% the radius, and it emits less than 0.04% of the sun's luminosity. Its surface temperature is around 3,100 Kelvin compared to the sun's 5,778 Kelvin. And while the sun shines bright yellow-white, Barnard's star glows a deep, dusky red. Despite its small size, it's ancient, estimated to be 7 to 12 billion years old. That's nearly twice the age of our sun, a survivor from the early days of our galaxy. In the quiet corner of space it occupies, Barnard's star was more than just a fast-moving curiosity. It was a challenge, a puzzle. And for over a century, astronomers kept asking, could this tiny star harbor unseen planets of its own? For decades, Barnard's star was just a lonely traveler, close, fast-moving, and mysterious. But astronomers suspected more. A star that close couldn't be truly alone. In the 1960s, Dutch-American astronomer Peter van der Kamp made headlines. Using the Sproul Observatory's refractor telescope, he claimed to see slight wobbles in Barnard's star's position, tiny shifts in the sky. He believed these were caused by planets tugging gravitationally on the star. If true, they would have been the first exoplanets ever discovered. But the excitement didn't last. Other astronomers couldn't replicate his results. Eventually, the wobbles were traced back to instrumental errors, tiny adjustments made to the telescope after lens cleanings had introduced false signals. The planets, just illusions. And so, for decades, Barnard's star was left in silence, a ghost with no companions. But science didn't stop there. By the early 2000s, a new technique emerged: radial velocity. Instead of looking for wobbles in a star's position, scientists looked for shifts in its light spectrum. Tiny Doppler effects caused by the gravitational pull of orbiting planets. Using ultra-precise instruments like HARPS, the High-Accuracy Radial Velocity Planet Searcher, and later ESPRESSO on the Very Large Telescope in Chile, astronomers gathered over 20 years of data on Barnard's star. Then, in November 2018, the long wait ended. Led by Dr. Ignasi Ribas of the Institute of Space Studies of Catalonia, an international team brought the first real evidence. After compiling 2 decades of precision radial velocity data from 7 observatories, including HARPS, UVEs, and HIRES, They spotted a tiny, rhythmic wobble in the star's velocity, a 233-day cycle, caused by an unseen companion tugging gently on the star. The statistics were overwhelming. A 99.8% chance that the signal was a planet. They named it Barnard Star B, a super-Earth, about 3.2 times Earth's mass, orbiting at roughly 0.4 astronomical units, just outside the system's snowline, where temperatures fall so low that water and gases like CO2 freeze into solid ice. It receives less than 2% of the sunlight that Earth does. That translates into a surface temperature around minus 170 degrees Celsius. If Barnard Star B could hide in the noise for so long, what else might be lurking there? The silence was broken, and the breakthrough was coming. Then came the breakthrough. By the end of 2024, the search for exoplanets around Barnard's star had entered a bold new chapter. For decades, scientists had suspected that this quiet red dwarf was hiding secrets. The problem? Barnard's star is old, dim, and restless. Its surface is stirred by flares and magnetic noise, making planetary signals almost impossible to pick out. But everything changed with ESPRESSO, the Shell spectrograph for rocky exoplanet and stable spectroscopic observations, a marvel of modern engineering mounted on the Very Large Telescope in Chile. This wasn't just any instrument. ESPRESSO could detect the tiniest wobbles in a star's motion, less than 10 centimeters per second. It could catch the whispers of tiny planets tugging on their star from light years away. And it did. In March 2025, a global team of astronomers confirmed what had once seemed impossible. Barnard's star was home to 4 rocky planets. Meet the family. Closest to the star was Barnard Star D, a tiny world just 0.26 times the mass of Earth, orbiting blisteringly fast, once every 2.34 days. Just beyond it was Barnard Star B, a slightly larger world, 0.3 Earth masses, orbiting every 3.15 days. Then came Barnard Star C, orbiting every 4.12 days at 0.027 astronomical units, with a mass of 0.34 Earths, a compact rocky world. And finally, the outermost, Barnard Star E, the smallest of the 4 at just 0.19 Earth masses, yet the farthest out, completing one orbit every 6.74 days. It's still close to the star, but compared to its siblings, it lives in the star's cooler shadows. Their tight orbits suggest a remarkably compact planetary system, all 4 planets packed into orbits much closer than Mercury is to our Sun. These discoveries changed everything we thought we knew about Barnard's star. Once believed to be barren, it's now revealed to be a system rich with rocky worlds. For over a century, Barnard's star was a mystery, but now we know it hides 4 remarkable planets. It took decades of research and the sharpest tools to uncover this cosmic secret. Barnard's star isn't just a distant light. It's a window into how planets form and evolve. If you enjoyed this, like, subscribe, and hit the bell for more cosmic discoveries. Keep exploring.